Next condition is confidence interval estimator for the difference of means if the standard deviation is unknown, but take note, variances are unknown but assumed to be unequal. Okay? In our previous discussion, previous example, the variances are unknown but equal. This time, the fifth condition, confidence interval estimator for difference of means. The standard deviation is unknown, mean is not given, but take note, variances are unknown, but assume to be not, right, or unequal. Okay? So confidence interval estimator for difference of means and unknown standard deviation if independent samples are chosen from two normal populations with means mu sub 1 and mu sub 2. The confidence interval of their difference is given by mu sub 1 minus mu sub 2 greater than the difference of the two mean sample minus the margin of error, but less than the difference of two mean samples plus the margin of error. Okay, take note. Okay, if the sample size is less than 30, so we will be using the t distribution. Okay, if the sample size is less than 30, we'll be using the t distribution. To solve for the margin of error, E is equal to t alpha over 2 multiplied by the square root of the variance of the first sample divided by n sub 1 plus the second variance divided by n sub 2. Okay? Only if variances are unknown but assumed unequal. The degree of freedom is given by df is equal to first variance divided by the first sample size plus the second variance divided by the second sample size multiplied by n sub 1 minus 1 multiplied by n sub 2 minus 1 all over first variance divided by n sub 1 squared multiplied by n sub 2 minus 1 plus the second variance divided by n sub 2 squared multiplied by n sub 1 minus 1. Okay, so take note of this one. Okay, so we will be using these formulas if the sample size is less than 30 and if and only if the variances are unknown but assumed unequal. Okay? If the variances are unknown and assume na hindi sila equal, then we will be using this kind of formula. Okay? So for example, a professor teaches 2 sessions of the same course. One meets at 8 a.m. and the other at 10 a.m. Identical exams are given to both sessions. The professor suspects that their scores will differ on the average because of the question's leakage, leak for the exam. Because of the question leakage for the exam, a summary of the student scores are given below. Okay? So sample size 8 for 8 a.m. class and 8 for 10 a.m. class. The mean for 8 a.m. class is 72.625, and then the mean for the 10 a.m. class is 86.375. The variance of the 8 a.m. class is 353.125, and the variance of the 10 a.m. class is 87.125. Okay? Next. Find a point estimate of the difference between two mean score of the two sections. So we need to solve for the mean difference. Okay, the mean difference. So the mean difference of the two sections. So the mean difference of the two sections. So that will be 72.625 and 86.375. Okay. So 72.625 minus 86.375, so the difference, okay, the mean difference. So 76.625 minus 86.375. So the mean difference is 72.625. So the mean difference is 13.75. Okay? So the mean difference is 13.75. Negative here, negative sign here, it's not referring to the negative sign. It should be the difference, the mean difference of the two means is 13.75. Okay? 13.75. Next, letter B. Assume that the scores in the two sections are approximately normal with unknown and an assumed okay, with unknown and assume unequal variances. Construct a 99% confidence interval for the difference between the true mean score of the two sections. Again, in letter B, assume that the scores in the two sections are approximately normal with unknown and assumed unequal variances. Remember the discussion a while ago when we say take note that if the variances are unknown and assumed unequal, okay, we will be using the formula for this one. Okay, so we will be using this formula. So how do we construct the 99% of this particular problem with the condition that the variances unknown and assumed unequal? Okay, so how do we solve for that? So to solve for that, if the variances are unequal, okay, assumed unequal, how do we solve for the 99% interval, confidence interval? So to solve for DF, the formula is, okay, we will be using this formula if the condition is only if variances, population variances are unknown but assume unequal. So to solve for DF, or the degree of freedom, okay, is using this formula. So the first variance of the sample divided by the first sample size plus the second variance of the sample divided by the second sample size multiplied by the first sample size minus 1 multiplied by the second sample size minus 1. Okay? All over the first variance, okay, of the sample divided by n sub 1 raised to 2 multiplied by n sub 2 minus 1 plus the second variance of the sample divided by n sub 2 multiplied by n sub 1 minus 1. When we say n sub 1, n sub 2, you're referring to the sample size. Okay? So we have 353.125 divided by 8 plus 87.125 divided by 8 raised to 2 multiplied by 8 minus 1 times 8 minus 1 all over 353.125 divided by 8 raised to 2 multiplied by 8 minus 1 plus 87.125 divided by 8 raised to 2 multiplied by 8 minus 1. So your DF is 10.26. Okay? So you need to round up. So that will be 11. Okay? So that will be 11. Now, so since you already have the DF, which is 11, we can now solve for the T alpha over 2. Okay? So T alpha over 2. So in the given problem, so we need to look for the 99%, construct a 99% confidence interval. Okay? So if DF equals 11, so the T alpha over 2 will be, using the table, so using the T table, so DF is 11, so 99%, so this is the 99%, so DF 11, DF11, so that will be 3.106. Okay. Okay. So your T alpha over 2 will be 3.106. Okay. So T alpha over 2 is 3.106. Now, since you already have T alpha over 2, we can now solve for the margin of error. So the margin of error is T alpha over 2 multiplied by the first variance over the first sample size plus the second variance over the second sample size. Okay? So we can now solve. So margin of error is equal to 3.106 multiplied by the square root of 353.125 divided by 8 plus 87.125 divided by 8. Okay? So what will be the margin of error? So using a calculator, so we need to get a calculator. Okay? So we have 3.106 multiply by the square root of 353.125 divided by 8 plus 87.125 divided by 8. So the answer is 23.04. So 23.04. So your margin of error is 23.04. Okay, 23.04. Now, so after we solve for the margin of error, you can now identify the confidence interval. Okay, the confidence interval. So your confidence interval will be mu1 minus mu2 greater than the difference of two means, sample means. So sample 1 mean minus sample 1 means of 2 minus the margin of error, but less than the difference of two means plus the margin of error. So mu1 minus mu2 greater than the difference of two means. So we have 72.625 minus 86. Okay, mu to determine the 99% confidence interval. So mu1 minus mu2 greater than the difference of two means minus the margin of error, but less than the difference of two means, sample means, plus the margin of error. So mu1 minus mu2 greater than the difference of two means. So 72.625 minus 86.375 minus the margin of error, which is 23.04. But less than the difference of two means, sample means. So we have 72.625 minus 86.375 plus 23.04. Okay, 23.04, that's the margin of error. Okay, so therefore, that will be mu1 minus mu2 is greater than the difference of 36.69 but less than the difference of 9.29. Okay, so mu1 minus mu2, you're referring to the difference of 36.69 and the difference of 9.29. Okay, so therefore, okay, the 99% confidence difference, 99% difference, the 99% confidence, the difference between true mean score of the two sections is difference of 36.69 and 9.29. Okay, difference of 36.69 and 9.29. We're using this kind of formula. Yeah. Take note, only if variances are unknown but assumed unequal. Okay, assumed unequal. So in this particular example, okay, assume that the scores in two sections are approximately normal with unknown and assume unequal variances. So we will be using that kind of formula. Okay, so the next is condition will be confidence interval estimator for the difference of means related samples. For observations where the samples are related obtained by matching similar units, the differences of each pair is recorded. These differences have an average of D, okay, D bar, and has a variances of the given differences. Okay, has a variances of the given differences. The confidence interval of the population mean difference is given by mu sub 1 minus mu sub 2 greater than the mean difference minus the margin of error, but less than the mean difference plus the margin of error. Okay, and then to solve for E, T alpha over 2 multiplied by the standard deviation of the difference divided by the square root of n. So df in this particular, n minus 1. So we will be using this kind of formula if and only if the condition is confidence interval estimator for the difference of means related samples. Okay, so for example of this, okay, in a study of the effectiveness of physical exercise in weight reduction, a sample of 8 persons who engage in a prescribed program of physical exercise for 1 month showed the following result. Okay, so there are 2 groups, okay, before and after. So meaning we will be using this particular example if the given problem deals with dependent. Okay, meaning the first group will depend on the second group. Okay, or vice versa. So if the sample is dependent, if the problem deals with dependent, okay, dependent yung problem kasi may before and after, okay, pre and post, so those are the example of dependent variable. Okay, so if the given problem deals with dependent problem, so we will be using this one. Okay, the confidence interval estimator for difference of means related samples. They are related. Okay, related. If the given problems are related, so we will be using this one. Mu sub 1 minus mu sub 2 greater than the difference, the mean difference minus the margin error, okay, but less than the mean difference plus the margin of error. To solve for the margin of error, T alpha over 2 multiplied by the standard deviation, the difference of the standard deviation divided by the square root of n, and then the df, the degree of freedom, is n minus 1. So in this particular example, so we have weight, so before and after. So we do have 8 persons, okay, isang 8 person lang, ibig sabihin you only have 1 group. Okay, meaning these 8 persons, so meron silang before and after, so they are related. Okay, it's not composed of 2 groups. Hindi ito yung 2 different groups. There's only 1 group. Okay, 1 group, but you do have 2 experiment, 2 activities, before and after. That's why we call it related samples. So they are related samples. So we have 8 persons. So before, their weight are 209, 178, 169, 212, 180, 192, 158, 180. Then after, their weights are 196, 171, 170, 207, 177, 190, 159, and 180. Okay? So find the point estimate of the true mean difference between the weights before and after. So to solve for the point estimate, okay, to solve for the point estimate of the true mean difference, okay, when you say D bar, you're referring to the mean difference, okay, to the mean difference. So how do we solve that? So the solution is 3.5. So how do you get that? Okay. First, you need to get the difference of each. Okay. So the mean difference. So first, you need to get the difference. Okay. You need to get the difference. So 209 and 196, the difference is 13. 178 minus 171, you do have 7. 169 minus 170, you do have negative 1. 212 minus 207, 5. 180 minus 177, 3. 192 minus 190, you do have 2. 158 minus 159, you do have negative 1. And then 180 minus 180, you do have 0. So that's the difference. Now, to solve for the mean difference, you just simply add. So we have 13 plus 7 plus negative 1 plus 5 plus 3 plus 2 plus negative 1 plus 0. Divided by how many persons? How many persons? So you do have how many persons? So you do have 8 persons. Okay? So you do have 8 persons. So we have 13 plus 7 plus negative 1 plus 5 plus 3 plus 2 plus negative 1 plus 0. So divided by 8, so you do have 3.5. Okay? So you do have 3.5. Okay? 3.5. So that is your mean difference. Now, to solve for the standard deviation of the mean difference, okay, this one we call it the standard deviation of the mean difference. To solve for the standard deviation of the mean difference, this one. What do you call this? Standard deviation of the mean difference. To solve that, that will become, okay, the square root of 13 minus 3.5. Okay, 13 minus 3.5 squared plus 7 minus 3.5 squared plus negative 1 minus 3.5 squared plus 5 minus 3.5 squared plus 3 minus 3.5 squared plus 2 minus 3.5 squared plus negative 1 minus 3.5 squared plus 0 minus 3.5 squared. All over n minus 1. So you have 7. Okay, n minus 1. Remember in solving for the standard deviation of the sample, summation of x minus the mean over n minus 1. So in here, in solving the standard deviation of the difference of mean, okay, the mean difference, so ito yung difference. Okay, yan yung difference. So yung mean difference is 3.5. So we have 13, okay, 13 minus 3.5 plus 7 minus 3.5 squared plus negative 1 minus 3.5 squared, and so on and so forth, divided by 7. Okay, well, how do you get 7? N minus 1. So using the calculator, okay, you check, it is 4.7809. So we have square root of 13 minus 3.5 squared plus 7 minus 3.5 squared plus negative 1 minus 3.5 squared plus 5 minus 3.5 squared plus 3 minus 3.5 squared plus 2 minus 3.5 squared plus negative 1 minus 3.5 squared plus 0 minus 3.5 squared divided by 7. So the answer is 4.7809. Okay? So the answer is 4.7809. Okay? Now we can now solve for we can now construct the 90% confidence interval. Okay? We can now construct 90% confidence interval. So construct the 90% confidence interval. So 90% confidence interval. So since the given sample size is 8, which is less than 30, okay, so we will be using T alpha over 2. And then based on the concept, okay, so your DF is equal to n minus 1. Why is it n minus 1? Because you only have one sample. Hindi siya group eh. One group lang, which is 8. Kaya n minus 1. So therefore, your DF is 8 minus 1, so you have 7. So that's your DF. So your T alpha over 2 with the 90%, okay, using the table, using this one. Okay, using this one. So 90% and then 7. So you do have 1.895. Okay, 1.895. Now, so how do we construct the 90% confidence interval? So given the T alpha over 2, which is 1.895, okay, so yung DF mo is 7. Miss bakit tingin 7? Kasi isang group lang yun eh. Okay, isang group lang. Although there are two activities, before and after. That's we call it related samples. Okay, the first activity is dependent on the second. Okay, so or vice versa. The second activity will depend on the first. So that's the related samples. So DF is n minus 1, so 8 minus 1, so you have 7. So to determine the 99% confidence interval, so we will be using T alpha over 2 because the sample size is less than 30. So using the table, you can get the T alpha over 2. So look for the 90% and then 7. So the intersection number is 1.895. Okay? Next. So to solve for the 90%, so we need to determine the margin of error. So the margin of error is T alpha over 2. The standard deviation of the difference, okay? The difference, the mean difference, the standard deviation. When we say S sub D, you're referring to the standard deviation of the mean difference divided by the square root of n. So we have 1.895. It's 90%. Okay, multiplied by 4.7809 square root of 8. Yeah. Okay. So you do have So our margin of error will be 1.895 times 4.7809 square root of 8. So that will be 3.20. Okay, 3.20. Okay, so we have 4.7809 square root of 8. So you have 3.20. So your margin of error is 3.20. Okay, so this is your margin of error, 3.20. Now, to determine, so your margin of error is 3.20. Now to determine the interval, so the interval will be mu1 minus mu2 greater than the mean difference minus the margin of error, but less than the mean difference plus the margin of error. So mu1 minus mu2 greater than, the mean difference is 3.5 minus 3.20, and then less than 3.5 plus 3.20. Okay? So that will become mu1 minus mu2 is greater than 3.5 minus 3.20. So the difference is 0.3, and then 3.5 plus 3.20, 0.70. Okay? So meaning, mu1 minus mu2 is greater than 0.3 but less than 6.70. Okay? So that is the 90% confidence. So therefore, with 90% confidence, okay, with the 90% confidence interval, the true percent, okay, so to determine the interval, so the interval will be this one, okay, so the interval of the related samples, so mu1 minus mu2 is greater than 0.3 but less than 6.7. So therefore, you are 90% confident, okay, what will be your conclusion? So your conclusion, with a 90% confidence interval, okay, the true mean difference between the weight before and after the physical program is 0.3 and 6.70. Okay, so with the 90% confidence, the true mean difference between the weight before and after the physical exercise program is between 0.3 and 6.70. Okay, 0.3 and 6, between 0.3 and 6.70. So that is the 90% confidence interval. Okay. Next is the confidence interval estimator for the difference of proportion. Okay? Difference of proportion. So the confidence interval of the difference of two population proportions, so P hat sub 1 and P hat sub 2 is given by the population proportion. Okay, the first population proportion minus the second population proportion is greater than the sample proportions, and the difference of sample proportions minus the margin of error, but less than the difference of two sample proportion plus the margin of error. Then to solve for the margin of error, z alpha over 2 multiplied by the square root of p hat sub 1 times q hat sub 1 divided by n sub 1 plus p hat sub 2 multiplied by q hat sub 2 divided by n sub 2. Okay, this is applicable for the large samples from Bernoulli distributions. Okay. So for example, a school administrator wants to investigate the effect of climate on students' attendance in school. Two groups of students were selected at random, one group from the uplands and the other from the lowlands. Of the 3 students from the uplands, 72 were absent from the school for at least 1 day during the semester, and 400 students from the lowlands, 70 were absent from the school for at least 1 day. Construct the 95% confidence interval for the difference between the true proportion of students from the uplands and lowlands who were absent from the school for at least 1 day during the semester. Okay, during the semester. So how do we construct the 95% interval? Okay, so to construct a 95% interval for proportion, population proportion, we need to use the formula. Okay, what are those formulas? This one. Okay, first solve for the margin of error. To solve for the margin of error, so that will be z alpha over 2 multiplied by p hat sub 1 multiplied by the square root of p hat sub 1 times q hat sub 1 over n sub 1 plus p hat sub 2 multiplied by q hat sub 2 over n sub 2. Okay, then after that, we can now solve for the interval. Okay, confidence interval. Okay, so first, So we have n sub 1, which is 300, n sub 2, which is 400. Okay? For n sub 1, which is 300, so there are 72 were absent. And then for 400, there are 70 were absent. So this is for uplands. And then the other one is lowlands. Okay? For the uplands, there are 300 students and there are 72 were absent. For the lowlands, there are 400 students and there were 70 were absent. So to solve for the p hat sub 1, so that will be s over n. So you have 72 over 300. So what is 72? 72 divided by 300. So you have 0.24. Okay? Next, q hat sub 1, just simply subtract. So 1 minus 0.24. So 1 minus 0.24. So you do have 0.76. Okay? Then repeat the process. So p hat sub 2. So you have 70 divided by 400. So we have 70 divided by 400. So 70 divided by 400. So you have 0.175 or 0.8. So 0.8. So q hat sub 2. So that will be 1 minus 0.18. Okay. 70 divided by 400, that will be 0.18. So q hat sub 2, that will be 1 minus 0.18. So you have 0.82. Okay, 0.82. So since you already have p hat sub 1, q hat sub 1, p hat sub 2, q hat sub 2, we can now solve for the margin of error. Okay? So margin of error. So p hat sub 1, 0.24, q hat sub 1, 0.76, p hat sub 2, 0.18, q hat sub 2, 0.82. So we can now solve for the margin of error. So margin of error, z alpha over 2 multiplied by the square root of p hat sub 1, q hat sub 1 over n sub 1 plus p hat sub 2 multiplied by q hat sub 2 over n sub 2. Okay? So what is your z alpha over 2? So the given there is 95. So 95%. So using the table, okay, this one, so using this table, so identify the 95% of z alpha over 2. So 95% z alpha over 2 is 1.96. Okay? So 1.96 z alpha over 2, 1.96. And then just simply substitute. So substitute now. Square root of 0.24, 0.76 over 300 plus 0.18, 0.82 over 400. Okay? So your margin of error, so we have 1.96 times 0.24, 0.76, 300 plus 0.18, 0.82, 400. No, that would be 0.06. So it should be 0.06. Okay, now, so after that, we can now solve for the margin of error. Okay, and the margin of error is 0.06. So after we determine the margin of error, which is 0.06, we can now solve for the interval. So the interval will be population proportion. Okay, when we say P here, you're referring to the population proportion minus the second population proportion is greater than. So first population proportion minus the difference of the population proportion. So we have P1 and then P sub 2. When we say P here, you're referring to the population proportion. So it's greater than the difference of the sample proportion minus the margin of error, but less than the difference of sample proportion plus the margin of error. Okay? So we have the difference of population proportion is greater than, okay, the difference of sample proportion. So we have 0.24 minus 0.18 minus 0.06, but less than 0.24 minus 0.18 plus 0.06. Okay, so using the calculator, so we have 0.24 minus 0.18 minus 0.06. So we have population proportion is greater than 0, but less than 0.24 minus 0.18 plus 0.06. So you have 0.12. Okay? So meaning the 95% confidence interval. Okay? So with the 95%, confidence, so the difference. So the difference between the true proportion of the students from uplands and lowerlands, okay, who were absent from school for at least 1 day during the semester is 0 up to 0.12. Okay, 0 up to 0.12. Okay, 0 up to 0.12. So that is that is the solution for the confidence interval estimator difference proportion where n is greater than equal to 30. Okay, n is greater than equal to 30. Okay, that's all. Thank you.